Hello GATE aspirants. Welcome to part 14 of GATE Electromagnetic Theory series. Question number 31. Consider an isolated magnetized sphere of radius r with a uniform magnetization m bar along the positive z direction, with the north and south poles of the sphere lying on the z-axis. It is given that magnetic field inside the sphere is b bar is equal to 2 mu naught by 3 m bar, where mu naught is the permeability of vacuum. Which of the following statements are correct? Option A, the bound volume current density is 0. Now volume current density Jb is equal to curl of m bar. And here it is given that it is uniformly magnetized object. So for uniformly magnetized object, Jb is equal to 0. For uniformly magnetized object. So this means option A is correct. The second option, the bound surface current density has maximum magnitude at equator, where the magnitude equals magnitude of m. Now Kb is equal to m bar cross n cap, where n cap is the outward normal to the surface. Now if we consider at equator, then at equator n cap is perpendicular to m bar, and if it is perpendicular, then that means this will be m magnitude of m into magnitude of n cap into sine theta, and sine 90 it will be 1, so this will be same as magnitude of m bar. So option B is also correct. Then for option C, the auxiliary field h bar is equal to minus 2 by m bar. Now h bar is equal to b bar by mu naught minus m, and b bar is given, it is 1 upon mu naught, and b bar is 2 mu naught by 3 m bar minus m bar. So mu naught will cancel, 2 by 3 minus 1, so this will be minus 1 by 3 m bar. So it is minus 1 by 3, not minus 2 by 3, so option C is wrong. And for option D, far from the sphere, the magnetic field is due to dipole moment m bar, where m bar upon 4 pi r cube is equal to b by 2 mu naught z cap. Now magnetization is this capital M bar is equal to magnetic moment per unit volume. So from here, magnetic moment is equal to volume into magnetization, and volume will be 4 by 3 pi r cube into m bar. So that will be magnetic moment. And if you want to find out magnetic field of a dipole, then magnetic field of a dipole, for a dipole, this will be B is equal to mu naught upon 4 pi into m by r cube. In bracket we have 2 cos theta r cap plus sin theta theta cap. This is the formula. Now we are considering at large distance. So this is along z axis, and at large distance this theta will be simply 0. So if you put theta is equal to 0, then this B is equal to mu naught upon 4 pi into we have m by r cube, and theta is 0, that means this will be 2 into r cube. So this will be B bar. And now this mu naught upon 4 pi, this is given here, this will be from this expression itself, we can write mu naught into m upon 4 by r cube is equal to into 2 is equal to b into z cap. So this will be b into z cap. So it is satisfying the equation. So this is option D. Option D is also correct. Next question. Question number 35. An electric field as a function of radial coordinate r has the form E bar is equal to alpha e raised to minus r square upon r into r cap, where alpha is a constant. Assume that dimensions are appropriately taken care of. The electric flux through the sphere of radius root 2 centered at the origin is phi. What is the value of phi upon 2 pi alpha? Now flux is equal to, it is surface integral 1 of E bar. So this will be equal to, now we will write here value of E bar, where we will substitute r is equal to that radius, and into dA will be r square into sine theta d theta d phi r cap. So the product of these two, so this will be alpha e raised to minus capital R square upon r into, we have r square here, and this is integration over theta and phi. So this means theta goes from 0 to pi and phi goes from 0 to 2 pi sine theta d theta, and this is equal to 4 pi only. That means phi is equal to e raised to minus r square into, we have alpha into r, and this is 4 pi. So from here phi upon 2 pi alpha is equal to 2 will be here. So this will be 2 into r into e raised to minus r square. But r is root 2, so this will be 2 root 2 e raised to minus 2. And this comes out to be 0.3827. And rounding off to 2 decimal places, this is 0.38. So this is the answer. And answer given in the answer key is 0.36 to 0.40. Next question. Two independent electrostatic configurations are shown in the figure. Configuration 1 consists of an isolated point charge q is equal to 1 coulomb, and configuration 2 consists of another identical charge surrounded by a thick conducting shell of inner radius r1 is equal to 1 meter and outer radius r2 is equal to 2 meter, with the charge being at the center of the shell. W1 is epsilon naught by 2 E1 square dV, and W2 is equal to epsilon naught by 2 volume integral of E2 square dV, where E1 and E2 are the magnitudes of the electric fields for configurations 1 and 2 respectively. Epsilon naught is the permittivity of vacuum, and the volume integrations are carried out over all space. If 8 upon epsilon naught W1 minus W2 is equal to 1 by n, then what is the value of the integer n? Now here we will calculate the work done. So in first case, W1 is equal to, this is equal to epsilon naught by 2 integration. So this will go from r to infinity, and first is E1 square. E1 square is 1 upon 4 pi epsilon naught upon q by r square, the whole square. So this is E square, and into we have volume integral. Now in the spherical coordinate system, we will consider that d tau is equal to r square sine theta dr d theta d phi, but that integration over d theta d phi, that comes out to be 4 pi. So this will be 4 pi into r square into dr. So this is equal to, here we have 4 pi and outside 4 pi, so 1 4 pi will cancel out, 1 epsilon naught will cancel out, and this 2, so this will be 8 into pi into epsilon naught. Also this q square we can take common, so then we have integration from r to infinity 1 upon r square dr, and this integration is minus 1 upon r. So this is q square upon 8 pi epsilon naught into minus 1 upon r. So W1 is equal to q square upon 8 pi epsilon naught. First is 1 by infinity, that is 0, minus 1 by r. So let me take some other letter here, 1 by r. So this will be into 1 by r. So that is 1. Similarly, we have to calculate for second one. Now for second one, epsilon naught by 2, then we have integration 0 to infinity. Now here we have two regions. One is this of radius r1, and then this is r1 to r2. Now this is conducting, that means here electric field will be 0. So inside electric field will be because of this charge, and also we have to calculate for outside field as well. So W2 is equal to, we have epsilon naught by 2, then first is r2 r1, and that is 1 upon 4 pi epsilon naught into q by r square into 4 pi r square dr plus 0, and outside of it, so plus r2 to infinity and again it will be 1 upon 4 pi epsilon naught. Then we have q by r square here, the whole square, into 4 pi r square dr. So this we have to solve. So W2 is equal to, now from this we can take similarly as we have done in case 1, we can take this q square upon 8 pi epsilon naught common, and then we have minus 1 upon r. Here we have minus 1 upon r, and limit is from r to r1, plus we have minus 1 upon r, and limits are from r2 to infinity. So this comes out to be q square upon 8 pi epsilon naught. This will be minus 1 upon r1, minus minus plus 1 upon r, and plus 1 upon r2. So now W1 minus W2 is equal to q square upon 8 pi epsilon naught into this subtraction of these two. So that will be 1 by r1 minus this. So W1 minus W2. So this 1 by r will cancel. So this will be in bracket 1 upon r1 minus 1 upon r2. But here it is given r1 is 1, r2 is 2. So this will be 1 minus half, that is half. So this will be half into q square upon 8 pi epsilon naught. That is W1 minus W2. And here q1 is also given, q1 is 1. So this will be, numerator is 1 square, so that is 1 only. So this is what we are getting. Now in the question it is asked 8 pi by epsilon naught. But if we consider 8 pi epsilon naught in bracket W1 minus W2, then this comes out to be 1 by 2, and by comparison we can write n is equal to 2. So there was this mistake in the question itself. This epsilon naught should be in the denominator, but in the question it is wrongly given in the denominator. So for this particular question, marks were given to all. This was a MTA question. But if we consider 8 pi epsilon naught like this, then answer will be 2. Next question. Consider an electromagnetic wave propagating in the z direction in vacuum with the magnetic field given by, this B bar is given, where B0 is 10 raised to minus 8 Tesla. The average power passing through a circle of radius 1 meter placed in the xy plane is P. Here epsilon naught is 10 to the power minus 11. What is the value of 10 raised to 3 P by pi? Now intensity is equal to power upon area, and intensity can be written as 1 upon 2 mu naught into B0 square into C. So from here power is equal to B0 square C into A upon 2 mu naught. And we want to calculate this part. So let us multiply and divide by pi. So 10 raised to 3 P by pi. This can be written as B0 square C, and this is pi r square upon 2 mu naught. So divide by pi and multiply by 10 raised to 3. So B0 square into C into r square into 10 raised to 3 upon 2 mu naught. Now we have C square is equal to 1 upon mu naught epsilon naught, and here we have C by mu naught. So from here C by mu naught is equal to 1 upon C by mu naught can be written as, so multiply and divide by C. So this will be, or I can write value of 1 by mu naught only. So this will be epsilon naught into C square. So we will substitute this here. So 10 raised to 3 P by pi is equal to B0 square, and 1 by mu naught is epsilon naught into C square. So this will be epsilon naught C cube into R square into 10 raised to 3 upon 2. So this is equal to B0 is 10 to the power minus 8. So this is 10 raised to minus 16 into epsilon naught is 10 raised to minus 11. C cube, so that is 3 cube, that is 27 into 10 to the power 8 3s are 24 into R square, distance is 1 meter, so that is 1 square into 10 raised to 3 upon 2. So this will be equal to 27 by 2. Now 20 4 plus 3 is 27 and 16 plus 11 is also 27, so that will cancel out. So this is equal to 13.5. So answer is 13.5 and answer given in the answer key is 11 to 13.7. So these were all the questions from GATE 2023 paper. If you like this video, please give it a thumbs up and subscribe to my channel for more videos. Keep learning.